Leetcode 2560, House Robber 4. Rob at least k non-adjacent houses. Capability is the max you take from any one house, we want the minimum capability. Example, rob 2 houses. Best choice is indices 0 and 2, capability 5. Other choices give 9. So we return 5. This is a binary search problem. We want the minimum capability. For any candidate cap we can ask, is cap valid? Meaning, can we rob at least k non-adjacent houses such that every house we rob has value at most cap? If a cap is valid, any larger cap is also valid. So we're looking for the smallest valid cap. That's binary search on the answer. We need a check function. For a given cap we only allow houses with value at most cap. Then we greedily pick as many non-adjacent houses as we can from left to right. If we get at least k picks, cap is valid. Example, check 5. Houses with value at most 5 are at indices 0, 1, 2. We skip index 3. Greedy, pick 0, skip 1 because it's adjacent, pick 2. That's 2 picks, at least k, so check 5 is true. Check 3, only houses with value at most 3 are indices 0 and 1. Greedy, we pick 0, then we can't pick 1 because it's adjacent. So only 1 pick, less than k, check 3 is false. How do we find low and high? The answer is the minimum capability, so it's the maximum value among the houses we pick in some valid robbery. That maximum is always one of the house values. So we only need to search among values that appear in the array. The simplest range is low equals min of nums and high equals max of nums. Here min is 2 and max is 9, so we search in the range 2 to 9. Variables, low and high are the search range, low is min of nums, high is max of nums. Cap, or mid, is the candidate capability we are testing. Check of cap asks, can we pick at least k non-adjacent houses with value at most cap? Steps, for check of cap we only use houses with value at most cap. We greedily scan left to right, pick if allowed and not adjacent to the last pick, count picks, and return true if count is at least k. For the binary search, if check of mid is true we try smaller by setting high to mid, else we try bigger by setting low to mid plus 1. The answer is low. For this example we have established the lower and upper bound, low is the minimum house value 1 and high is the maximum 9. Index 0, value 2 exceeds cap 1, skip. Index 1, value 7 exceeds cap 1, skip. Index 2, value 9 exceeds cap 1, skip. Index 3, value 3 exceeds cap 1, skip. Index 4, value 1 within cap, pick. Count is 1. So we get 1 picks, less than k, check returns false. Index 0, value 2 within cap, pick. Count is 1. Index 1, adjacent to last picked, skip. Index 2, value 9 within cap, pick. Count is 2. So we get 2 picks, at least k, check returns true. So at the lower bound check fails, and at the upper bound check passes. Is the upper bound the minimum we can do, or can we do better? To find the smallest capability that still works, we use binary search. We binary search on capability. The teal segment is our range from low to high. At each step we take mid and run the check. If check is true, we shrink from the right, if false, from the left. The smallest capability for which check is true is the answer. Step 1, low 1, high 9. Mid is 5. Check of 5 is true, so we set high to 5. Step 2, low 1, high 5. Mid is 3. Check of 3 is true, so we set high to 3. Step 3, low 1, high 3. Mid is 2. Check of 2 is true, so we set high to 2. Step 4, low 1, high 2. Mid is 1. Check of 1 is false, so we set low to 2. The minimum capability is 2, the smallest value for which we can rob at least k non-adjacent houses. N is the length of nums, m is the range from min to max, time is O of n log m. We do log m binary search steps, each with an O of n greedy check. Space is O1, only a few variables. Main function, binary search on capability from min to max of nums. While low less than high, mid is the guess. If we can pick at least k houses with value at most mid, set high to mid, else set low to mid plus 1. Return low. The check function, greedy scan, count non-adjacent picks with value at most cap, return whether count is at least k. Set search range to min and max of array. While the range has more than one value. Guess the middle. If check passes, try smaller capability. Otherwise try larger. Return the minimum valid capability. Check, greedy pick non-adjacent houses with value at most cap. Initialize count and last taken index. Scan each index. If house is under cap and not adjacent to last taken, take it. Return whether we got at least k picks.